All right, hi folks, how are we doing? So in this lesson, we're going to cover a few different applications of the trig functions that we've talked about already. So some things with right triangles, some things without right triangles, mostly things that involve the angles. So the first thing is sector and arc formula. So just real quick, what is sector and arc? So obviously area and circumference are pretty straightforward aspects of a circle. The sector is the area of part of a circle. So it's this region, whereas arc length would just be sort of the part of the circumference that's around that region, okay? So that's arc length versus sector. So in our formula, it seems really complicated, but it's really not. Your sector, if it's radians, we use pi over 2 and x. If it's an angle like degrees, we use the angle over 360. But basically all it is it's whatever fraction of the circle, okay, these are just the fractions of the circle, times either the area formula for sector or times the circumference formula for the arc length. So basically what we're saying is if we know the circle of an area is 80, and we want to find 1/4 of that because of the angle that we're given, we just do 1/4 times the total area, and that gives us the area of that region. So it's more of a proportion more than anything else. We're just multiplying it into area and circumference. So don't overthink these formulas. It's literally what is the fraction of the circle that we're dealing with, and then you just multiply it by circumference for arc length and area for sector. So let's try it here. So let's say I have a circle with a radius of 10 inches. So right off the bat, that means the circumference would be 20 pi and the area would be 100 pi, right? Just applying circumference is 2 pi r, area is pi r squared. Okay, do me a favor too. Do not use the decimal of pi unless we are using it for like a word problem. So something like, how much area would it be for a piece of wood or something like that. We tend to keep this stuff in pi a lot of times. Now it says find the area of the sector and the arc length created from a central angle of 120 degrees. So if I draw my circle, a central angle is the angle from the center of the circle out to the region. So still, in a circle, that's a total of 360 degrees. So in terms of the fraction of the circle, it's 120 degrees out of 360 degrees. So effectively, I want 1/3 of my circle. So this is our fraction of the circle. So to find the sector, all I do is I take the fraction and I multiply it by the area, which I already pre-calculated at 100 pi. So 1/3 times 100 pi. And we can just write that as 100 pi over 3, and this is in inches, so inches squared. That's it. That's all you got to do. And then arc would be 1/3 times the circumference of the circle. Again, calculated ahead of time, 20 pi, so 20 pi over 3. And arc is in inches because it's just one-dimensional, so that's it. That's all you got to do. Now, in this question, what is the angle intercepted of the intercepted arc of 42-inch arc length on a 12-inch radius circle? So again, let's try to draw the diagram here. So I've got a circle. The length of the arc was 42 inches. And the radius of this circle was 12. And we want to find the middle angle. So our formula for arc is arc equals the angle over 360 times the circumference of the circle, which is 2 pi r. Realistically, I have everything I want. The arc is 42 inches, angle over 360 stays, times 2 pi, we know the radius of the circle. So what we end up with is 42 equals 24 pi times the angle over 360. So it's just a two-step problem after I do a little bit of cleaning up from plugging in. So 360 times 42 gets me 15,120 equals 24 pi times the angle, and I divide both sides by 24 pi. Sometimes it's easier to write the angle in terms of radians, but in this case, it doesn't specify, so I'm just going to use degrees. Be very careful, though, when you put this into your calculator. So if I do this of 24 pi like that in my calculator, you should end up with 200.5 degrees. Be careful. If you put it in your calculator like this, you've actually put it in incorrectly. Your calculator reads pi slightly differently than other numbers. So if you are dividing by pi, what you want to do is you want to do 15,120 divided by parenthesis 24 pi. If you missed it, you're going to get a much bigger number than that, what I have. Your calculator reads it weird. So whenever you're putting pi in and not by itself, it's best to put it in with parentheses. Now, the other part of applications that I want to cover is what we call the law of sines and the law of cosines. Now, your law of sines is a pretty nice little formula here. I don't want to go through the whole exact proof of it, but basically the way that it works is if I create a right triangle here, I have my hypotenuse in the center, and I'm just going to really focus on angle A and angle C here. So you can see right here, I have a right triangle, and the sine ratio of A in that right triangle is hypotenuse over C. Right? If I had to redraw this, capital A, hypotenuse, there. If I focus at C, I have my right triangle this way, and angle C, my ratio for the sine of C, is the hypotenuse over A. If I look at how these two things are related, do you see how they both have h in the middle of the equation? So here's what I'm going to do. I'm going to isolate it for h. H equals small c times sine of capital A. Just multiply both sides by c. In this one, I'm going to multiply this by a, multiply that by a. I get this equation. H equals a times sine of capital C. Well, now these two equations are technically equal. So I'm allowed to say c times the sine of A equals a times the sine of C. And what we do is you basically divide both sides by AC. Because that way it returns the variables back to normal. So we get this ratio. Sine of A over A equals sine of C over C. So that's a little mini proof for you. I mean, that's all there really is to it. But the way that it works is as long as you have an opposite angle to side, we can use the law of sines. That's the key. So let's look at an example here. So let's say I call this angle A, angle B, angle C. And the side across is little a, little b, little c. Since I have capital angle A and side A, I can go sine of 35 over 7 has to be in proportion to any other set of opposite sides and angles. So in this case, sine of 105 over x. Now, this is just a cross multiply and divide type of situation. Just be very aware that these values are in degrees. So if you're doing this in your calculator, you will want to use degrees. So if I cross multiply, x times sine of 35 equals 7 times sine of 105. You could, if you wanted to, you could put this into your calculator as is. If you do that now, it's 6.7, of course it is, 6, okay? Now we can divide both sides by sine of 35. I would recommend that you put this in as one fraction. and you're going to want to use parentheses for it. So 7 sine 105, in your parentheses, divide that by sine of 35. Okay? So if we do that, 7 sine 105 divided by sine of 35, I get approximately, and it's a little bit of a rounding, but 11.788. So that's the length of that side. Now, if you're unsure of whether you did it right, you at least need to double check to make sure. Proportionally, it makes sense. 35 to 7, 105 to x. At least those values make sense because this should be the largest side of the triangle in the first place. So, given that in a triangle A is 63 degrees and side A is 5.5, side B is 4.7. The first thing you need to do every single time where you get this is you need to draw a triangle. And I recommend drawing the triangle the same way every single time. A, B, and C. I basically always make the letters that they give me the base letters. That way I never have any issues with some of our other problems coming up. So, angle A is 63 degrees. So that's here. Side A was 5.5. And side B, which is across from angle B, is 4.7. So what we do is we look at, again, I have a matching side angle here. I want to know this angle here. So I can say sine of 63 divided by 5.5 needs to be in proportion to sine of B over 4.7. And again, this is just a cross multiply type of a question. So 5.5 sine of B equals 4.7 sine of 63. Now 4.7 sine of 63 gets me about 4.188 with some rounding. That's 5.5 sine of B. Divide that by the 5.5, and I get 0.761, so close, equals sine of B. Now again, if I'm looking for the angle, I need to do the inverse function. So that's second sine of 0.761. And so that means my angle would be 49.59 degrees here. Okay, that's all we really have to do with this. And now given that in triangle A, so once again, they give us a triangle. So we're going to draw A here. That's 33. Side 6. Side C. So I want to make this angle C. Again, it doesn't really matter which way the letters are lined up. What you may notice is if I draw the triangle, I always draw this flat side here. And side C is 10. Okay? So this is the same exact problem. So why don't you pause the video here, try to solve it, and when I re-enter it, I'll have the answer just written up here for you with some work, okay? So pause it now. Okay, so by the time I set that up and solve it, you do the proportion. You get sine inverse of 0.91, and that's 65.51. And so that's one of our angles. The thing is, and you might already see it right here, this is what we might call the ambiguous case. There's actually two possible triangles. And the way that I do this every single time is in this part of the sentence right here. The key to identifying this case is if the side of the unknown angle is larger than the side of the known angle. So A is the known angle. Its side is 6. C was the unknown angle. Its side was 10. So because the side of the unknown angle was bigger than the side of the known angle, that means this can actually work one of two ways. So here's how this kind of visualizes. So let's say that side was 10. We already have that. This is A. This was C. And we knew that this side here was 6. The thing is, 6 can go down this way like how we draw it, but technically it can have pivoted inward that way. So we basically get one of two possible triangles. One where the side goes out, and one where the smaller side goes in like that. in which case we probably have more of an acute triangle here, not every single time, but this one will always pretty much be an obtuse angle. So what we just solved for is we always solve for this case, the case where it swings out. So we know that this is one of the potential angles. The thing is, if I know that is the angle, it's possible that for this particular problem, this angle could be the other one. So the key is, how can I find that angle? And we need to use a little bit of knowledge about triangles to do it. So there's not much we can say about this triangle because we only know one angle, but we do know two sides that are equal, which means this is an isosceles triangle. And if you recall, isosceles triangle have two equal sides as well as two equal angles that form the equal side lengths. So if we found this angle, we know that this angle must also be 65.1 degrees. So really it comes down to what is the relationship of these two angles. And if you remember in geometry, two angles with a shared side have to be supplementary, which means they have to add up to be 180. So if you're looking for the ambiguous angle, first identify that the side of the unknown angle is bigger than the side of the known angle. Find the angle, and then the ambiguous angle will always be 180 minus the solved angle. So 180 minus 65.51 gets me, 114.49 degrees. So that's a really particular case, but the reason why I've been asked you to draw it the same way every single time is because that is the easiest way to help you identify this. So please draw it that way. Okay? And then how long is the base of the isosceles triangle with each leg 27 centimeters and the base angles are? So in case you are unaware of all these properties, so isosceles and the base angles are the two equal angles. So that means this is 23, this is 23. And what that means is these sides are equal. Each of these are equal, so it's 27. And we're asked to find the base side. That's the side that connects the angles. What we want to find is this angle. And the angle in a isosceles triangle that is not one of the base angles is what we call the vertex angle. Okay, the vertex angle is basically the unequal side, or the unequal angle. So again, there is something that we do know about triangles. If I add and subtract, we know that the vertex angle is 134 degrees. And now that I know that angle, I now have two different ratios I can apply. First, sine of 134 over x equals sine of 23 over 27. Now, one other option that we've talked about before, if you're trying to solve for the variable in the denominator like this, you can cross multiply, but you can also just take the reciprocals and reset up the equation so now the variable's up top. This is a much easier strategy because now you can just multiply by sine of 134 on each side and plug that into your calculator. 27 times sine of 134 over sine of 23. And so that gets me the base length of 49.707 centimeters here.